Welcome to Lesson 9, the closer for Stage 3, and the moment system security stops feeling like trivia and starts feeling like a superpower. Lesson 7 gave you App Armor, which is powerful but expensive to roll out. Today we go declarative. 1 service block, 10 directives, and Nginx drops from a 9.6 unsafe score down to 1.8 OK, read-only.usr, PrivateTmp, NoNewPrivileges, capability bounding, all for free. By the end, you'll also know exactly when to reach for systemed versus when App Armor is still the right tool. So let's put these two tools side by side. App Armor gives you per-path read-write-execute granularity, but you pay for it. 2 weeks in complain mode, agenprof and alogprof rituals, and a fresh profile every time the binary upgrades. System directives trade that surgical precision for speed. A declarative block inside the unit file, applied on reload, validated with system analyze, and shipped right alongside the service. The honest answer isn't either or, it's both. Systemed as the baseline for every service, App Armor layered on top for your crown jewels. And the first line we add to that baseline is ProtectSystem, the single biggest score mover in your toolkit. Off is the default, the traditional Unix free-for-all, where the service writes wherever DASI permits. Flip it to true, and your binaries and libraries go read-only, knocking 0.8 off the score. Go strict, and you also lock down, etc., leaving only .iproc, dev, and temp writable for a full 1.6 reduction. Start at strict, then carve out exceptions with read-write paths for the log and state directories your service actually needs. Now zoom out and look at the full menu. Systemed ships over 100 security directives, but these 10 do roughly 80% of the work. And stacked together, they're what takes Nginx from 9.6, unsafe, down to 1.8, OK. Notice the heavy hitters, ProtectSystem at -1.6, capability bounding set and system call filter, both at -1.5. We'll walk each one in turn, and by the end you'll have a 10-line service block you can paste into any unit file. Let's start with the two easiest wins, PrivateTmp and ProtectHome. PrivateTmp gives Nginx its own PrivateTmp namespace. The service sees an empty directory, while the host quietly stashes the real files under JASTA-TMP, system private ABC NNGINXX, and wipes them on shutdown. That kills X11 race attacks and leftover crash dumps in one line. ProtectHome goes further. Home, root, and run user simply vanish from the service's view, so even if an attacker pops a shell inside Nginx, they can't cat anyone's bashuk or exfil an SSH key. 2 directives, 2 whole classes of attack gone. Now we move from file system isolation to privilege isolation. Linux capabilities shatter root into 38 distinct powers, and Nginx really only needs one of them, cap-net bind service, to bind port 80. So we drop everything with capability bounding set, add just that one back as an ambient capability, and pair it with NoNewPrivileges SOG true, so no setuid binary in the process tree can ever climb back up. Then restrict suds GID, restrict namespaces and lock personality, slam the side doors, no new setuid files, no container escape namespace tricks, no ABI shenanigans. Even with a remote code execution, the attacker is stuck with the powers of an unprivileged web server. And here's how we actually measure all of this. Systemed Analyze Security gives every unit an exposure score from 0 to 10, lists every directive you're missing, and quantifies exactly how much each one costs you. Out of the box, Nginx scores 9.6 unsafe, running as root, full access to home, shared TMP, the works. Drop in a 10-line override with ProtectSystem, ProtectHome, PrivateTmp, NoNewPrivileges, and that single capability, reload, and the same command returns 1.8. OK. Same binary, same traffic, a fraction of the attack surface. So here's the actual drop-in, the whole thing. Save it to etc. system nginx.service.de, hardening.conf, daemon reload, restart, and you're at 1.8. File system locked down, capabilities trimmed to just cap, net bind service for port 80, kernel and namespaces sealed off, syscalls filtered to the system service set, and address families restricted to what Nginx actually needs. The same skeleton drops cleanly onto PostgreSQL, Redis, your own Go binary. Just swap the read-write paths and you're done. Now, when do you reach past system for AppArmor? Here's the honest split. For about 70% of services, your standard daemons, anything that just needs read-only confinement, dropped capabilities, and a score you can validate, systemed alone is the right call. You layer AppArmor on for the other 30. Custom internet-facing code, compliance targets like PCI or HIPAA, or anything with a known abuse history and a big blast radius. Defense in depth means systemed is the baseline everywhere. AppArmor guards the crown jewels, and audit watches both. Before you ship that unit file, let me save you 5 outages I've watched happen. ProtectSystem Dark Strict will break any app that writes to, etc. Punch a hole with read-write paths instead of loosening the whole directive. Never edit unit files in lib directly. The next apt upgrade wipes them. Always use systemctl edit so your override lands in, etc. and survives. An empty capability bounding set drops everything, including caps the service actually needs, so peel them off one at a time. System call filter, e.g. system service, is a solid baseline, but add a timer or whatever group your app actually uses. And finally, edit, daemon reload, restart, analyze. Skip the reload and you're scoring the old config while patting yourself on the back. So zoom out, that's stage 03 in 6 skills. ProtectSystem with its 3 levels, the top 10 directives you'll actually reach for, PrivateTmp and ProtectHome to isolate the file system, capabilities and NoNewPrivileges to kill escalation paths, systemed analyze to measure the win, and finally the judgment call on when AppArmor earns its keep, baseline in systemed heavyweight confinement for the high-value or regulated workloads. Stage 04 takes this declarative baseline and scales it. CIS benchmark walkthrough, Ansible for fleet rollout, and the capstone checklist that ties it all together. And that closes stage 03. AppArmor, Audit D, and Systemd, Mac, Audit, and Service Hardening, all checked off. Lesson 10 opens stage 04 with the CIS benchmark walkthrough, and here's the quiet payoff. Because you've already done lessons 01 through 09, most of those 200+ controls are already green. Linus and OpenSCAP will confirm it. Then Ansible for the fleet and the production checklist to land the plane. See you in stage 04.